A visitor from the depths of the universe is hiding behind the sun, and no one has fully unraveled its secrets. Behind the sun's blinding light, in a place inaccessible to the human eye, Atlas was waiting. It hadn't vanished yet, but its every movement thrilled the scientific community. This third known interstellar visitor was not just a distant comet, but a mysterious guest whispering the secrets of the universe. Even the official announcements were surprising. The chemistry of Atlas was unusually strange. Carbon dioxide was prominent instead of water, at a ratio of 8 to 1, a value previously unseen for a comet. The step-by-step increases in its brightness revealed a veil of secrecy that no model could predict. Observatories worldwide were tracking Atlas closely. Every new signal, every small change was recorded. The time for its disappearance hadn't arrived yet, but preparations for the critical days ahead had begun. Scientists were wrestling with a question. Is this object merely an interstellar wanderer, or does it bear the traces of a conscious design? Images obtained since June confirmed that this object does not belong to our solar system. Its speed, trajectory, and behavior were completely different from classical comets. Astronomers had the opportunity to observe an interstellar visitor in real time for only the third time in history. Atlas is still being observed and may offer new surprises at any moment. This object was much more than an ordinary comet. It was a door to the mysteries of the universe, and observers eagerly awaited what the upcoming period would bring. When the size estimates arrived, everyone was stunned. The core of the object looked massive, likely the largest interstellar object ever detected. Its mass was calculated to be in the tens of billions of tons. But its size was not the only remarkable feature. The cloud of gas and dust surrounding the nucleus, the coma, was active even when still very far from the sun. Normally, comets at this distance are still dormant, but Atlas was already awake. With every new image, the excitement grew. A race against time had begun. Observatories across the globe reorganized their plans to collect as much data as possible within a limited window, because this opportunity would be brief. For planetary scientists, it wasn't just about a single comet. It was a chance to test what might be possible in other star systems. The discovery of Atlas was more than a data point. It was a gateway to space, and a global observation campaign had now commenced. Toward the end of October, a challenging period approached. Atlas was about to pass behind the sun. No telescope on Earth would be able to look in that direction. This meant that for 3 weeks, this mysterious visitor would be completely invisible. During this process, only spacecraft in the inner regions of the solar system would be able to see anything. Satellites in Mars's orbit would continue to observe as long as the angles were suitable. But for Earth, this meant a period of complete darkness. There were no real-time images, no light curves, and no new spectrum data. The last usable data was collected around October 21st. Then, everything fell silent. This wasn't just a technical glitch. It was a strategic blind spot, because a highly critical period was to occur between the end of October and the beginning of November. The perihelion passage on October 29th, the closest approach to the sun, could cause extreme heating, outbursts, fragmentation, or changes in its trajectory. But no telescope would be able to see it during this time. Hidden behind the sun, untouchable, unobservable, it was in a place where no one could reach it for 2 critical weeks. And so, 3I/Atlas, the third known interstellar visitor, disappeared at the end of October 2025, precisely at the moment when its chemistry began to change unexpectedly. Official reports called it an exotic comet, an unprecedented composition with carbon dioxide at a ratio of 8 to 1 compared to water. Its brightness was increasing in step-like fashion. No model could fully explain this behavior. All the major observatories fell silent simultaneously, because Atlas had entered the sun's bright blind spot. This was a planned silence. A global team was preparing for its return. The one question on everyone's mind was Atlas an ordinary cosmic traveler or proof of something deliberately designed? Now the stage was about to reopen. The real test was about to begin. The system's automatic tracking algorithms flagged its orbit as hyperbolic. This means an object not bound to the sun, one that came from deep space and will return there. A few hours later, old images from June were found. These frames both confirmed the trajectory and established that the object did not belong to the solar system. Astronomers had succeeded in observing an interstellar visitor at the moment of capture for only the third time in history. The name Atlas placed it in a very special category alongside Oumuamua and Borisov. However, the initial data suggested this object was even more unusual than its predecessors. The pace of observation was incredible. Every 24 hours, Atlas scanned the southern sky, comparing every new signal with a growing archive. The team led by Dr. Hein Mizik discussed the data moment by moment, aware that even a single error could misdirect science for years. A great sense of urgency was felt in the initial draft reports. Was it truly interstellar, or just an extremely active comet? The answer was hidden in the numbers. Its escape velocity exceeding 58 kilometers per second and its trajectory, coming directly from the direction of Sagittarius, confirmed it was not bound to the sun in any way. Towards the end of October, Earth's telescopes went quiet, but Mars was still watching. Satellites in the orbit of the red planet had the opportunity to look at Atlas from an angle no one on Earth had before. On October 3rd, 2025, Atlas approached Mars to within about 0.05 astronomical units, opening the door to the clearest images yet. Dr. Emily Gyro of the European Space Agency was the head of the imaging team at the time. She was a scientist who liked to take risks. "This opportunity won't come again," she declared, dedicating the entire observation time of the Mars Express and ExoMars Trace Gas Orbiter, TGO, satellites to Atlas. The plan was bold: to take rapid exposures, each only 5 seconds long, in a region where the background was 30 times brighter than normal. The result more than paid off the risk. TGO's Cassis camera and Mars Express's high-resolution channel captured the core of Atlas with unprecedented clarity. An asymmetric coma and a teardrop-shaped dust tail were clearly visible in the images. Spectrometers analyzed the composition of the surrounding gases, while the Omega and Spicum instruments created distribution maps of the volatile substances. Although the data arrived with a delay of hours, sometimes a day, these observations filled a very critical gap. While Earth-based telescopes were disabled by the sun's glare, the Mars-based teams kept the story alive. Every change in brightness, every shape deformation, every chemical signature was meticulously recorded. Gyro's risky decision saved the story of Atlas from being completely shrouded in darkness. The October 3rd campaign not only closed the gap, but also laid the foundation for observations to be made when Earth regained sight. Scientists now had a solid reference point. Before the end of November, the world's most powerful telescopes were ready to reactivate. Atlas was about to emerge from behind the sun. The European Southern Observatory's Very Large Telescope, VLT, prepared a special observation plan for the beginning of December. This massive system, combining light from 4 separate 8-meter mirrors, was sensitive enough to resolve the core and dust cloud of Atlas on a 100-kilometer scale. The goal was to detect every change in the tail, every new dust jet, or any possible fragmentation. Meanwhile, the JUICE spacecraft, heading toward Jupiter, also came into play. Its primary mission was to study Jupiter's moons, but engineers didn't miss the opportunity. As Atlas passed through the outer solar system, the ultraviolet and infrared spectrometers aboard JUICE would examine its composition from a different angle. This could either confirm or refute the anomalous carbon dioxide and organic matter data obtained from Earth. Time was short. JUICE could only observe after Atlas began moving away from its closest approach to the Sun. This window was limited to a few weeks. On Earth, giant telescopes like the VLT and Gemini were collaborating. A global network was established to track light curves, rotation speed, and potential trajectory deviations. The goal was clear: to capture even the smallest deviation and record Atlas's behavior flawlessly. About a dozen different observing instruments were preparing to work simultaneously. This would be the most comprehensive observation campaign ever conducted on an interstellar object. All eyes were now on Atlas. As Atlas returned, the debates grew. Every new piece of data deepened the question of whether it was natural or artificial. On one side were the planetary scientists, attempting to explain Atlas's extraordinary behavior with volatile substance physics. On the other side was a more cautious group, suggesting that conscious design might be behind this. According to some scientists, the carbon dioxide-heavy composition of Atlas was highly revealing. An extreme difference like 8:1 compared to water could indicate that the core formed in a very cold, carbon-rich disk. Some argued that cosmic rays created a hard crust on the surface during its interstellar journey, trapping water vapor and allowing only more volatile gases to escape. In this case, the strange step-like changes in brightness could be explained by localized gas jets erupting from under the crust. However, not everyone was convinced. Spectroscopy expert Dr. Elena Vagra pointed out that there was too much order in Atlas's behavior. Such symmetry is rare in nature, she stated. Atlas's almost perfectly round core was far removed from typical comets. Most comets have patched, mountainous, and irregular surfaces, but Atlas was almost as smooth as an engineered product. There was also the timing issue. Atlas followed an orbit that made it completely invisible behind the Sun precisely while passing between Mars and Jupiter. To some researchers, this seemed overly coincidental. Moreover, if those light bursts truly repeated at specific intervals, they could be controlled energy releases rather than natural gas eruptions. For Vagra, the real test lay in the details. Were there on/off-like transitions in the light curves or random flares? Was the sharp boundary of the coma the result of natural jets or the edge of an artificial field? The scientific world was divided, but they all agreed on one sentence. Extraordinary claims require extraordinary evidence. The observation window was about to open, and everyone held their breath. Atlas was preparing to emerge from behind the Sun telescopes, spacecraft, and scientists were in position. Would every new piece of data reveal the comet's naturalness or the clues of a conscious design? No one knew yet. Atlas's unusual behavior, its smooth round core, and sharp coma boundaries only fueled the curiosity. The step-like increases in brightness in the light curves and the repeating signals created both excitement and speculation in the scientific community. It remained to be seen whether every measurement would be explained by natural processes or provide hints of a deliberate arrangement. Now all eyes are waiting. Scientists eagerly await the data to be collected in the coming weeks to illuminate Atlas's nature. One thing is certain: Atlas is not an ordinary comet. It is a door opening to the mysteries of the universe, and the upcoming observations offer a critical opportunity to unlock the secrets of interstellar visitors.